Hello everyone, my name is Lubna Fidos and I'm from Priyadashini College. So today my task is the chatbot with PDF using RAG pipeline. So the goal is to implement a retrieval argument generation RAG pipeline that allows users to interact with the semi-structured data in multiple PDF files. So the system should extract, chunk and embedded and store the data for efficient retrieval. It will answer the user queries and perform the comparisons accurately. It leverages the selected LLM model for generating responses. So what it does is first it extracts the text from the uploaded PDF and then it splits the text into chunks for efficient retrieval. And next, the embeds the chunks into a files which is a library called Facebook AI Similarity Search Index for semantic search. And it uses the GPT model to answer user queries based on the retrieved chunks. Here we use the key libraries and the tools like Streamlit, Files, Sentence Transformers, PDF Plumber, OpenAI API. For using here, this OpenAI API uses the GPT model to generate the answers. And coming to the Streamlit library, it's a Python framework for building interactive web apps. And coming to Files library, it's a fast and efficient similarity search and clustering of dense embedding. And next, coming to the sentence transformer library, it provides the pre-trained models for generating the sentence embedding. And next, the PDF plumber, it will extract the text from the given PDF, which we uploaded in the chatbot. So finally, we should import all these libraries like LangChain, Streamlit, PDF Plumber, NumPy, Files, Sentence Transformer, the LangChain dot splitter, and and we also have to import the dictalist any and OS library. These imports include the modules for text splitting, handling PDFs, and semantic search, language models, and Streamlit. So coming to the class RAG pipeline. So this RAG pipeline class encapsulates the entire process of the PDF text extraction, semantic indexing, and retrieval augmented query generation. Here, the attributes of the class are model. It uses the sentence transformer for generating embeddings. And next, it uses the attribute index. It creates a files index to store and search embeddings. And next, it uses the chunk metadata attribute. It stores the metadata for chunks. Example, the chunk text and the corresponding page number. And next, coming to the attribute text splitter, it splits the text into manageable chunks using LangChain's recursive character text splitter library. And then coming to API key, it manages the OpenAI API key for GPT integration. And next coming to LLM attribute, it instantiates the OpenAI GPT model for generating the answers. And in last, retrieval prompt. It defines a structured prompt template for GPT to retrieve information. So these are those attributes, this text splitter, chunk size, index, model. So these are used for attributes used in a class called RAG pipeline. So this RAG pipeline class is the backend of the application. It does all the heavy lifting. Next, coming to this init method, it's a pipeline initialization. What it does is it setups the RAG pipeline with a sentence transformer model to create the embeddings and a files index to store and retrieve these embeddings and a text splitter to break documents into smaller chunks in order to process the large PDFs efficiently and an open AI language model for generating answers. It accepts an OpenAI API key for connecting to the GPT. And here we use the key variables like self model to generate the embedding for the text. And the self index, a fast index, it's a fast index, FAS index to store embeddings of the document chunks for similarity searches. And a self text splitter variable which splits the text into smaller pieces like 500 characters with the 50 character overlaps. Next, next coming to the extract text from the PDF method. So before that, here we'll using the try block and then accept the block. Here we'll keep the here this code, this try block. Here this is a model name which is the GPT 3.5 Turbo, and my OpenAPI key is this in OpenAI API key. Here I sub added my OpenAPI key. And next, if any exception error occurs, then it shows the error initializing OpenAPI, and then it returns. And next, coming to the extract text from PDF method, what it does is it reads the content of a PDF file and extracts the text from the each page using PDF Plumber library, and it stores the extracted text in a dictionary where the page number is the key. And next, coming to the chunk text method, what it does is it breaks the extracted text into smaller chunks using the recursive character text splitter. These chunks are easier for the model, process, and store. Next, coming to this process documents method, what it does is it takes the uploaded PDF files and extracts their text and then splits the text into chunks and converts them into embeddings and stores these embeddings in the files index. So that overall process is like first step is to extract all the text from the PDF. And the second is it breaks the text into smaller chunks and then it encodes the chunks into numerical vectors using the sentence transformer model. And later it stores these embeddings in files along with metadata. Example, the chunk text and its page number. And next, coming to the search document method, what it does is it searches the files index to find the chunks of text most relevant to a user's query, and then it passes the retrieved chunks as context to GPT for generating an answer. Here the overall steps are: first step is to convert the user query into an embedding, and later second step is that it searches the files index for the most similar chunks, like top 5 by default, like for example. And next, the third is it combines the retrieved chunks into a context string, and then it uses a retrieved based prompt template to generate a final answer from the GPT. So here I'm using my PDF is this cloud, for example, this cloud computing PDF I'm using in order to get the answers, and by giving the query, the answers will be generated from this GPT. Next, coming to this main, here what it shows in the output, like here the overall, in this overall task, this Streamlit app is the main function. This Streamlit app is the front end of the application. It provides a simple web interface for the users where we upload our PDFs, and by entering the query, we'll get the answers. So here in that interface, we'll get the title as a chat with PDF using RAG, and then we'll enter the OpenAI API key, which is unique for me, and then I'll load the PDF, and after entering the query, I'll get the answer regarding that query. So here the variable is query equals to st.text input. Here the input is enter the query. It asks that enter the query, and then by clicking this get answer button, we'll get the answer from that PDF. So the key features of this Streamlit is the slide bar input for API key, Key features of this Streamlit interface is the slide bar input for API key where we insert our API key, and then the PDF uploader where we upload our PDF, and then the query input and the answer button. Let me show you the output. So let me show you the Streamlit interface. And the command is Streamlit space run space our program name. Then enter. We run this code in the Streamlit app. Streamlit run space and a program name. So this is what the Streamlit interface. Here it gives the title as a chat with PDF using RAG, and there's a slide bar. Here we have to enter our key, which I have already created the key open API key. So enter it. Then so finally it shows to upload the PDF files. So drag and drop here. So I'm browsing. So yeah. Next, I have to enter the query. So I've already used. Here I'm asking the high performance computing. It's a context. So here we need to give the context comma the query according that related to that context. This is how the chat with PDF using Rack will be run. So after uploading this, here we entered it, and here I got the answer. So this is how it works. It's about the oral task, that is chat with PDF using RAG pipeline. So finally it is done. Thank you all guys.